You are welcome back to Indicated. This is mathematics. So I'm gonna show you today uh, something strange, quite strange. This is I'm talking about a projectile under this gravitational acceleration, right? Okay, and also I wanna discuss some geometrical properties or characteristics regarding this projectile. Right, okay. Let's see how we can explain that. First of all, I'm gonna show you guys this projectile under gravitational acceleration. This under this gravity, under this field, there is a parabolic shape. So you guys know that that's a parabolic shape. We can prove that mathematically, but here I'm gonna show you how to do it properly, right? So let me take a couple of axes here uh, to this direction, right? And this direction. Okay. Let's make some calculations with simple equations. Okay. Let's start it by here. Let me imagine that this is the origin, right? And this is x-axis and this is y-axis, because once you turn around it, once you rotate it about 90 degrees, you can realize that it looks like a parabola, which follows up this equation y squared is going to be equal to 4 times a times x, because I need to show you some geometrical characteristics regarding this projectile. Okay, so without wasting time, let's go for the calculation. And the distance which is measured along x-axis, let me call this little x, right? And the distance measured along y-axis is called something little y. Let me make some constructions here properly. Here, there are some distortions in my figure. Hope you may understand that because due to this blackboard I am using currently, right? Because there is something issue with my light board. Hope to get it back as soon as possible, right? Okay, so this is x and this is y. Okay, now this is the starting velocity u, right? And you know that if the angle between this horizontal line and this direction to the projectile starting direction is theta, right? Then these two components can be written as u cos theta and u sin theta, right? I know that you are really familiar with this one, but here I'm gonna show you the nice relationship and some interesting characteristics, right? You can think about the projectile from here to there, but here I'm gonna write down some equations from O to B, right? From O to B. Let me write down them from O to B. From O to B across along x direction, we can write down by putting s equals to ut plus 1/2 times a t squared. So what is this little x is going to be equal to, you know that let me consider this starting point now, right? So you can calculate them in advance. You know this is zero vector, and what is this across here? Yeah, this one is always this constant u cos theta, that is known as u cos theta, right? Okay, so let me simplify it. Then little x is going to be equal to u is just 0 times t times you are working downward, so plus 1/2 times plus t squared, right? This is your first equation between x and t, right? Okay, let me write down another equation following up the same uh, Newtonian mechanics equation, right? The equation which is coming with Newtonian mechanics, right? And then the y is going to be equal to here. I'm pretty sure that you can write down it to yourself, right? Little y is going to be equal to u cos theta times t, right? U cos theta times t, then make little t the subject and substitute it on this one, right? Okay. You know, with conic section, I have taught you in advance, right? You know, with conic sections, yeah, this is just zero, right? Let me show you some uh, how it will be look like once we substitute it. Then I will explain it. Furthermore, x is going to be equal to 1/2 times g times and y upon little y upon u cos theta is squared of that, right? Okay, then you can make little y squares the subject, because we know the geometry regarding parabola with conic section. It's coming with y squared is going to be equal to 4yx, right? You know what does it mean by little a? Little a is nothing as the direct which is forming this parabola, right? Okay, let's see what is the direct, then we can we'll be able to find out the focus of this focal length of that particular parabola also. It means that the focal length of this projectile, the locus of the projectile, right? Or the locus of the projectile, what I have interpreted here, right? Okay, let me show you. Y squared is going to be equal to 2 times u squared times cos squared theta upon g times little x, right? Okay, so this is what according to the geometry of parabola. You can see here y squared is going to be equal to 4 times a times x. So I'm really sorry, this should be 2, right? So we know that 4a is going to be equal to 2 times e squared times cos squared theta upon g, right? Okay, so let me simplify it furthermore. You can see here little a is going to be equal to u squared times cos squared theta. Oh, on the other hand, you can tell the same as, yeah, let me change my color. U times cos theta is the component toward horizontal direction, right? And upon here, what this is just g 2g. Yeah, you know that this is what this is the height. If you're gonna make the same projectile without making an angle, it means that if you're gonna do the same projectile with same, sorry, we need to do furthermore calculations. This is just the direct, right? This is the direct. I will show you. We have to go furthermore to show you some more geometrical characteristics, but here we could find out the direct. Let me show you the direct here, right? Let me change the color. This is the direct, sorry. Okay, this is the direct of this particular projectile, right? And also you know that same height along these symmetrical axes, here. From here to there, this is direct, which was given by u squared, u times cos theta squared of that upon 2g, right? And also that is the focal length as well, right? That is the focal length as well. So in this video, I could show you that in the basic geometrical properties with a projectile under gravitational acceleration in this earth, right? So we could compute focal length and directs in my next video. I hope to discuss what are the relationships how we can explain furthermore between projectile between an inclined projectile and vertical projectile under this gravity, right? Okay, so for now, I'm gonna stop it by here, right? And also, thanks for watching. I am Sapumal Sena Dirogi Sasanka Sagar.